Think about the sheer mass of modern civil infrastructure. We are talking about millions of tons of steel, concrete, and glass, all locked together in a highly stressed, interconnected matrix. To keep these massive structures standing and prevent catastrophic failure, every single beam and panel has to perform exactly as expected. Historically, the only way to guarantee that performance was to rely on rigid, time-tested recipes. Engineers depended entirely on the published Indian Standard, or IS codes, which dictated the exact chemical and physical makeup of every accepted building material. But the modern construction industry is evolving faster than those lists can be updated. Laboratories are constantly developing sustainable alternatives, recycled composites, and advanced synthetics. This creates a critical bottleneck. You have a highly effective new material, but you cannot legally build with it because it doesn't have an IS code yet. Drafting, testing, and publishing a formal national standard for a single novel material can take years. That chronological gap between laboratory development and formal standardization actively blocks builders from using better, cheaper, and greener methods in the field. A modern building code cannot survive purely on historical lists. It requires a dynamic mechanism to safely absorb and verify unknown technologies. That mechanism is built directly into the National Building Code of India 2016, specifically Part 5. This specific volume governs the quality and deployment of all building materials across the country. It is the definitive legal rulebook for what can and cannot be used in Indian construction. The foreword reveals a critical shift in logic, a preference for a performance-oriented approach rather than prescriptive approach. The older approach dictated exact material compositions, prescribing the exact ratio of clay and sand in a brick, a fixed recipe. A performance-oriented approach flips that logic. It evaluates the measurable output of a material. It asks how much weight the brick can hold, how it reacts to fire, and how much it insulates, regardless of what it is actually made of. Part 5 operates as a legally binding, algorithmic pathway for evaluating and deploying the technologies of the future. For conventional components like cement and structural steel, the baseline prescriptive method still applies. The code maintains a traditional categorization framework, organizing familiar materials into 26 primary principal categories, with strict adherence to existing IS numbers. This makes sense for materials that have required massive manual production and traditional standardization for decades, like basic clay masonry. However, the code immediately introduces a modern disruption in Clause 3, outlining a clear mandate for sustainable materials. This clause directs builders to utilize materials that reduce solid waste generated and lower the environmental impacts associated with production and delivery. It pushes the industry to prioritize options that use renewable energy in their extraction and minimize the depletion of natural resources. The conflict: highly sustainable, novel materials inherently lack decades of traditional IS standardization. To use them, engineers need a completely different legal pathway. That pathway is Clause 4, new or alternative materials. This is the operational filter bridging experimental research and legal field implementation. The core operating rule here is vital. Just because a material does not have an existing IS standard does not mean it is banned from use. Unstandardized materials can be approved by demonstrating performance equivalent to what the code requires. To prove this, the code deploys a rigorous 19-point testing matrix. Every proposed new material is measured against parameters A through T. This flowchart visualizes how the parameter list functions as a multi-dimensional testing gauntlet. First, the material must clear the structural gates. It passes exact tests for structural stability, strength, and dimensional stability. Next are the critical safety thresholds. Its fire safety and thermal properties are subjected to extreme limits. Then comes long-term viability. Engineers simulate decades of wear through accelerated tests for durability and UV resistance. Finally, it faces the ecological and chemical gates, passing strict reviews for overall environmental aspects and proving absolute non-harm regarding toxicity. Clause 4 replaces subjective historical judgment with an objective, data-driven system evaluation. But who is actually responsible for executing this 19-point evaluation? The legal burden of proof falls entirely on the owner or the agent proposing the material. They assume all responsibility and all costs for proving its viability to the authority. Clause 8 Methods of Tests, dictates exactly how this proof is gathered. It strictly requires authentic laboratory test data, documented field trials, and detailed historical study data to substantiate any performance claim. The industry is far past the days of intuition-based compliance or relying solely on older historical checks. The modern code demands verifiable, rigorous laboratory execution. Clause 5, third-party certification, serves as the critical buffer against biased manufacturer data. The authority utilizes these independent, government-recognized third-party certification schemes to guarantee that the requisite quality parameters are actually met off-site during mass production. For an innovation to survive, it must complete the full compliance loop: private research and development data, verified by independent laboratory testing, leading to final authority evaluation and legal deployment. This performance-oriented process actively shapes modern infrastructure. Because of this pathway, the code already explicitly recognizes a massive range of unconventional materials that have successfully navigated this performance filter. The list includes everything from decorative concrete and dry mix mortars to nanotechnology-based advanced materials and geopolymeric cement. This is how an entirely unconventional material safely transitions from an unknown laboratory variable to a fully integrated legal structural component. The mechanism in Clause 4 actively pulls the national construction industry forward, rather than anchoring it to the materials of the past. NBC Part 5 represents an evolution in regulatory philosophy. It functions as a dynamic interface, a precise bridge connecting established infrastructural safety with future technology. It acts as an uncompromising filter, blocking dangerous, untested materials from entering the market, while simultaneously fast-tracking proven, sustainable innovations. For the modern architect or engineer, engineering compliance no longer relies on searching a 26-chapter index for a specific IS code to tick a box. True modern compliance is about proving a material's capability against a comprehensive, real-world matrix of physical, chemical, and environmental parameters.